In the previous video, I talked about finding compound interest and present value. In this video, we are going to discuss a formula having to do with an annuity. Many people have an annuity that they are using as a retirement savings plan. In an annuity, a certain amount of money is put into an account on a regular basis, and that money gains interest throughout the time it is invested. It is different than a compound amount, because in a compound amount, a certain amount of money is invested right at the beginning, but no more money is added. Here is the formula that can be used for an annuity. And once again, I have what all the variables stand for down at the bottom. I do want you to pay particular attention to a couple of things here. First of all, notice what the I is equal to. The I is the interest rate per compounding period. It is not just whatever the interest rate is. And there are a couple of I's in the formula that you will have to work with. Also, the N is not the number of times per year. It is the total number of payments throughout the life of the annuity. So the variables do not mean exactly the same as they do in the compound amount and the present value formulas. On the next page, we will go through and do an annuity problem. Suppose that once per month, $50 is put into an account that pays interest at an annual rate of 6% compounded monthly for 10 years. How much money will be in the account after 10 years? When I go through and do a problem like this, the very first thing that I do is I go through and I figure out what my I is equal to. I, in this particular case, it's the interest rate per compounding period. So the interest rate being 6%, I'm going to write it as 0.06, and it says per compounding period. Well, it's compounded monthly, so there are 12 months in a year, so I is equal to 0.06 divided by 12. If I go through and I use a calculator to figure that out, I get I is equal to 0.005. The other thing that I go through and do is I figure out what the N is equal to. The N is the total number of payments. And it says in the problem that I am going to put once per month $50 in. So there are 12 months in a year, and I am going to do that for a total of 10 years. So if I have 10 years times 12 months per year, that means that N is going to equal 120. So the very first thing that I always do is go through and figure out what the I is and what the N is, and then just go through and plug in everything. Now, of course, the R in this case is how much money I am putting in each time, so that's equal to the 50. And then you just go through and plug in all the information that you have to get your answer. For the sake of time, I've gone through and put in all the numbers and done all the calculations for this particular problem. And I will let you go through and do exactly the same thing, if you'd like to, with your calculator to see if you get exactly the same things that I am getting. I do want you to pay particular attention to one area here. When I went through and did most of the calculations, I end up with 50 times 163.87934. I want you to think for a moment, if someone were to take that $50 and rather than putting it into an annuity, just stuffed it underneath their mattress for 10 years every single month, that would mean that they would have 120 $50 bills. Well, 120 $50 bills would give them a total of $6,000. But notice, doing it and putting that into an annuity means it's kind of like increasing from 120 $50 bills. They now have somewhere between 163 and 164 $50 bills. So they actually have more than $6,000. They have the $8,193.97. Having an annuity is very powerful, and there are certainly tax advantages as well to having an annuity, and you may want to talk to a tax advisor just to get more information about that. Okay, here's a problem that I'd like you to work on. Don is putting $2,000 every 3 months for 6 years into an account that pays 10% interest compounded quarterly. How much money does she have in the account after the 6 years? What I'd like you to do is I'd like you to pause this, go through and do the problem, and then start this back up again and see if you get the same answer. Okay, hopefully you've had time to go through and do the problem. The very first thing I would do once again with this problem is I would figure out what my I is. My I is the interest rate per compounding period. The interest rate is 10%, so I'm going to put 0.10. It says it's compounded quarterly, so it's 0.10 divided by 4. So using a calculator, 0.10 divided by 4 gives me 0.025. So that's what I is equal to. I also need to know what N is. N is the total number of payments. And once again, she's going to be making those payments every 3 months, which means 4 times a year. She's going to be doing it for 6 years. So the total number of payments is 24. So knowing what the I is and what the N is, first of all, makes this a little bit easier then to go through and figure out. Once again, in the interest of time, I have gone through and done all the work here, but I do want to point out to you once again that once I've gone through and done the calculations up to this particular point right here, and I get that equal to this 32.349038, once again, that's just an indication. I'm actually, when I put it into an annuity, I'm actually putting it in 32 times, not just 24 times. So I get a final answer of $64,698.07. Once again, I want to remind you that you will not need to memorize the formulas for the assessment. If you would like some additional practice, you can find some practice problems in this module.